There are also 3 other rules that can be useful to know. Actually, there are special cases of the rules we have already seen, but it's good to have them anyway for later on. So the first one we're talking about is taking the square of a sum. And as you know, a square is just a shorthand for multiplying a number with itself. So here now we could use the rule before, we multiply all combinations, and then we will get the following formula. But instead of doing that, we just write out the formula directly. So you could go this way, but just writing out the answer directly, you will get this. So this is a formula for squaring a sum. So for example, if I have 3 plus 4, I want to square it. Then the rule is square the first, square the second number, and then take the double product of the two numbers. Here is the product of the two numbers, 3 and 4. So this will become 9. So this is 12 times 2, so 24, and 16. This plus this is 40, so 49. So this is an example of this first rule, squaring a sum. Of course, we could have done it much more simply here, just adding first. We gotten 7, then squaring, we gotten 49. But that's not the point here. The point here is to understand this rule, because later on, when we're doing algebra, we don't have the options of adding here first, because there will be variables, x and y, so we can't do this step first. So you have to go and using this formula. And then there is another rule. You can also square a difference. And that, of course, means taking a minus b and multiplying by itself. Then the rule is exactly the same formula as the other one, but you put the minus here. So, for example, if I have 4 minus 3 and square it, then I should take 4 squared minus 2 times 4 times 3 plus 3 squared. So that's 16. And this 2 times 4 is 8 times 3, 24. And this is 9. So you see, if I add these two first, it's 25 minus 24, so this is 1. And that's, of course, you could see directly also here, 4 minus 3 is 1, and squaring 1 is 1. But again, later on we don't have the possibility of doing this subtraction first. So this is a formula here is called squaring a difference. Then there's also a third formula talking about taking the difference of two squares. So if I have a squared minus b squared, so here I take the difference of two squares, I can use the following formula if I like. And that's the same as this one. So taking the difference of two squares, I can instead write it like this. For example, if I have 5 squared minus 3 squared, then I can use this formula. So here a is 5, so this is 5, and b is 3. So this becomes 5 minus 3, and this becomes 5 plus 3. And this here is 2, and this is 8. So this is 16. So that's a way you can calculate a difference of two squares. Sometimes this formula become handy. So this is the formula for difference of two squares. This is the formula for squaring a difference. And this is formula for squaring a sum. All these three formulas follows actually from the formulas, the rules we have seen before. But is it handy to have a shortcut like this to write the formulas directly?